Hello and welcome to another session in mathematics. In this session we'll be looking at mensuration. Okay, but before we go on, let's take a preview of our previous lesson. Welcome back. In this lesson we'll be looking at area of sectors and segments, and then area of triangles. These are the areas we'll focus on in this session. Okay, and when we started this mensuration, I explained them sometimes we should be seeing as long as the word circle is concerned, as long as the shape circle is concerned. And on that day we talked about sectors, and we also talked about segments, and I told us that when we have this a radii forming something like this, forming a triangle in a circle, this point that is shaded is what we call segment. Okay, we call that what? Segment. But in a circle where we have something like this, inside here is what we call what? The sector. Okay, inside this triangle is what we call what? The sector. So we are not looking at the area of sectors and area of what? Segment, and also the area of triangles. And we'll quickly take some examples to illustrate that. Okay, let's quickly solve the question on the screen. Here's a diagram, and it says in the figure, a chord of a circle of radius 8 cm subtends an angle of 60 degrees at the center of the circle. Full stop. Find the area of the shaded segment. This area. So we should find the area of what? This segment. Okay. Solution. Okay, the area of this segment is given to be the area of triangle AOBC, okay, minus the area of triangle AOB. This is triangle AOBC, and then triangle AOB. Okay, so if we can find the area of this triangle AOBC and then find the triangle the area of the triangle AOB, then we'll subtract the triangle of AOB from the area of the triangle AOBC. So let us start. And the area of sector is equal to theta over 360 times 2 pi r squared. Okay, times 2 pi r squared. So let's write it down here. Theta over 360 times 2 pi r squared. Now theta from here is equal to 60 degrees. That's the angle of the triangle. We have 60 over 360 times 2 times 22 over 7 times 8 times 8, and if we express that, we have our answer to be equal to 33.52 cm squared. Okay, then we now solve for the area of the triangle AOB. Area of the triangle AOB is area of triangle AOB is equal to half AB times sin theta. Half AB times sin theta, where small letter a is the line facing this A, which is 8 cm. This is our small letter A. Small letter B is the line facing this. This is B. So we then have this to be equal to 1/2 times A is 8 cm, B is 8 cm times sine 60 degree. Are we following? Okay. At this point, we then have 1/2 times 8 times 8 times the value of sine 60 is 0.8660. Okay, and then this will give us 27.7 cm squared. Okay, now we have to find the area of the shaded segment in the question. The area of this shaded segment, like I told us, it is equal to the area of the triangle AOB minus the area of the AOB. Okay, so we start. For triangle AOBC, we have its area to be equal to 33.52. Triangle AOB is equal to 27.7 cm squared. Now we now have 33.52 minus 27.7. Okay, and then that will give us 5.82 cm squared as our answer. Okay, example number 2. Okay, we have example 2 on the screen. Says in the figure here, he said OPQ is a sector. OPQ is a sector of the circle center O. MNO is an equilateral triangle of area 8 cm squared. If the radius of the circle is 3 cm, calculate the shaded portion of the triangle. Calculate the shaded portion of the triangle. Okay, let us start. Area of cure OP is equal to theta over 360 times pi arrow squared. Okay, that is the area of our QOP. Okay, is equal to theta over 360 times pi arrow squared. Okay, then substitute the values. We have our theta to be 60 degrees over 360 times 22 over 7, and then times 3 times 3. Okay, where 3 is the radius of the circle. Okay, then if we do that, we have our answer to be equal to 4.7 cm, and then we look for the area of the shaded portion. The area of the shaded portion. Okay, we are told from the question here that the area of the triangle is 8 cm squared. The area of the triangle is 8 cm squared. So have area of the triangle 8 cm squared. 8 cm squared. Therefore, the area of the shaded portion is then equal to 8 minus the value we got here, which is 4.7. 8 minus 4.7, and that will give us 3.3 cm squared as our answer. Okay, having studied the area of segments, sectors and triangles, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to cover areas like areas of triangle, areas of a sector, and areas of segment. And we'll stop here today. Do well to use the lesson note on the platform for further information on the topic we've just treated, and feel free to drop your question or comment on the comments box or section. Till we meet in our next class, stay safe and bye.